You have been standing in your yard looking at the birds, but the birds have not been looking at the same yard you have been looking at. What a bird sees when it looks at your garden, at its feeders, at the cardinal on the maple branch, at the flowers along your fence, is so different from what you see that calling it the same yard is almost misleading. There is a world layered over the world you know. Colors that have no names in any human language because no human has ever seen them. Patterns on plants that look plain to you and read like a neon sign to every bird that flies past. A navigational map written in the sky in a language your eyes have never had the hardware to decode. And the birds in your yard have been reading all of it every morning while you stood there thinking you were both looking at the same thing. Welcome back to Backyard Bird Mind. Subscribe before you leave, because today we are going somewhere genuinely extraordinary, inside the visual experience of a wild bird. Not metaphorically, literally. What the neuroscience and optics actually tell us about the world your birds inhabit every day, and what your yard, your feeders, and even the birds themselves actually look like from the other side of that experience. Stay until the end, because what we cover in the final section changes the way you understand every bird you have ever watched, and it is the part that takes the longest to fully absorb. Number 1, the fourth color your birds can see that you cannot. Start here, because everything else builds from this. Human beings are trichromats. We see color through 3 types of photoreceptor cells, sensitive to red, green, and blue wavelengths of light. Our entire experience of color, every sunset, every red cardinal, every green leaf, is constructed from combinations of those 3 signals. Birds are tetrachromats. They have 4 types of photoreceptor cells. The 4th type is sensitive to ultraviolet light, wavelengths shorter than the violet end of what humans can see, completely invisible to us without equipment. This is not a subtle difference in the richness of color perception. It is an entirely additional dimension of visual information that birds have access to and humans simply do not. Researchers at Lund University in Sweden studying avian color vision have documented that the addition of the UV channel does not just extend the spectrum birds can see. It creates entirely new colors, combinations of UV and visible wavelengths that produce experiences with no human equivalent. There are no names for these colors in any language because no human has ever perceived them. When your chickadee looks at your yard on a clear morning, it is seeing a version of that yard that includes colors and contrasts that are entirely absent from your experience of the same scene. The white snow in winter is not white to a bird. It reflects UV light and reads as something else entirely. The pale bark of a birch tree contains UV reflective patterns that make it visually complex to a bird in a way that looks plain and uniform to you. Here is what matters most. You have never seen your yard, not the version of it that exists. You have seen a version of it, the 3-channel version that human eyes can access. But the yard as it actually appears in the world, with its full spectrum of visual information, has been visible only to the birds. Number 2, what the cardinal actually looks like to other cardinals.
This is the one that most people find hardest to believe when they first encounter it. You look at a male northern cardinal and you see something extraordinary. The red is so vivid it seems almost artificial, a red that looks painted rather than natural, so saturated that it catches your eye from 40 feet away. You think you are seeing the cardinal at full intensity. You are not. The red plumage of a male northern cardinal reflects ultraviolet light in patterns that are invisible to human eyes. To another cardinal, or to any bird with tetrachromatic vision, the male cardinal looks substantially more vivid, more complex, and more dramatically patterned than what you see. The UV component of his plumage adds an additional layer of visual information that is entirely absent from your experience of his appearance. Research published in the journal Behavioral Ecology, studying northern cardinals, found that females use the UV reflective component of male plumage in mate selection. UV brightness in a male is a reliable signal of health, parasite resistance, and genetic quality. The females are not just choosing the reddest male, they are choosing the male who scores highest in a dimension of appearance you cannot perceive at all. The cardinal you have been watching for years, the one whose color still stops you mid-motion when he lands at the feeder, is even more spectacular than you have ever been able to see. What you experience as breathtaking is actually a reduced version of what he actually looks like. And this applies across your yard, the housefinch with his raspberry wash, the goldfinch in breeding yellow, the bluebird with his electric back. Every bird you have ever called beautiful has been beautiful in a dimension beyond what you could access.
You have been admiring a shadow of what was actually there. Number 3. The invisible map written on your garden flowers. If the UV vision of birds were only relevant to plumage, it would already be extraordinary, but it extends into something that changes the way you see your entire garden. The flowers in your yard, the coneflowers, the black-eyed Susans, the native asters, the trumpet vine, look one way to you and completely different to a bird. Under UV light, many flowers reveal patterns that are entirely invisible to human eyes. Lines that point toward the center of the flower, rings that highlight the pollen, contrasting zones that mark exactly where nectar is available. To a bird, your garden is covered in signage. The plain-looking yellow coneflower that you deadhead in autumn is not plain to a hummingbird. It has directions printed on it in a color spectrum the hummingbird can read, and you cannot. The black-eyed Susan that looks like a simple dark center to your eyes has a UV pattern that functions like a landing marker, directing the bird precisely to the reward. Researchers at Queen Mary University of London studying UV patterns in flowers and their relationship to pollinator behavior found that the UV guides, called nectar guides, are among the most precisely functional visual signals in nature. They have evolved specifically to be visible to the visual systems of the animals that pollinate them, which is not us. This means that the native plants you put in your yard, the ones you planted for the birds and pollinators, are communicating with every bird that visits them in a language you cannot hear. They are saying, "Come here specifically, land here precisely. The reward is exactly at this location." And every hummingbird, every goldfinch, every warbler that passes through your yard is reading that communication fluently. Your garden is more informative than you knew, more directional, more alive with communication. You just cannot see the messages. Number 4, how birds see the magnetic field of the Earth. Here is where we move from extraordinary to something that most people take a moment to fully process. Some birds can see the magnetic field of the Earth, not detect it, not feel it, see it, as a visual experience integrated into their normal field of vision. Research into avian magnetoreception, the ability to sense magnetic fields, has produced increasingly strong evidence that certain species, including many migratory songbirds, use a chemical mechanism in their eyes called cryptochrome-based magnetoreception. The magnetic field triggers reactions in light-sensitive proteins in the retina that produce a visual signal, a kind of overlay on normal vision that indicates magnetic direction. Research teams at the University of Oldenburg in Germany studying European robins found evidence that magnetic sensing in these birds is light-dependent and processed through the visual cortex, meaning the birds are perceiving magnetic information as something they see, not as a separate sense divorced from vision. What does this mean for your yard? The robin that lands on your lawn on an April morning, the one that has just returned from its wintering grounds in the south, has navigated hundreds or thousands of miles using a compass built into its own eyes. It has been reading a map that is invisible to you, printed in the magnetic field of the planet, the whole time it was in the air above your house last night. Think about what that crossing actually looked like from the robin's perspective. Flying north in darkness, the stars above providing some orientation, and overlaid on the normal visual field, the trees below, the river ahead, the lights of the city, a directional indicator, not felt in the body like we might imagine, seen, a visual cue to magnetic north, as present and readable as a compass needle, built into the eye itself. The birds that visit your yard are not just visitors from the neighborhood. Many of them are continental navigators. They have seen the geography of North America from the air, reading it through visual systems more sophisticated than anything we have yet built, and they land at your feeder. Number 5, how their eyes are physically built differently from yours. The differences go deeper than just which wavelengths birds can see. The physical structure of a bird's eye is fundamentally different from a human eye,
in ways that make almost every aspect of their visual experience different from yours. Birds have a much higher density of photoreceptor cells in their retinas than humans do. A human retina contains roughly 200,000 photoreceptor cells per square millimeter in the fovea, the central region of sharpest focus. Some raptors have up to 1 million cells per square millimeter. Songbirds are not quite at raptor levels, but their photoreceptor density is substantially higher than ours, which means their visual acuity, their ability to resolve fine detail, is measurably sharper. The chickadee at your feeder can resolve detail in its environment that is invisible to you at the same distance. It sees the texture of bark at a range where you see a uniform surface.
It sees the individual features of insects that you cannot distinguish without magnification. It sees you, your face, your expression, your movement, in finer detail than you can see it. Birds also have a second fovea in most species. Humans have one foveal region of high-resolution vision. We point our eyes at what we want to see in detail. Many birds have two foveas, which gives them high-resolution vision in two directions simultaneously. They can watch for predators above and to the side while focusing on food directly below. They are doing two things with their visual attention at once that would require two pairs of human eyes to replicate. And the field of view. A human being has roughly 180 degrees of total visual field, with binocular overlap in the front, the region where both eyes cover the same space and depth perception is possible. Many songbirds have a total visual field of 300 degrees or more. They can see almost all the way behind themselves without moving their head. The blind spot behind a bird is smaller than you imagine. Almost nothing approaches a songbird without the bird knowing it is coming. There is one more structural feature worth understanding. Birds have oil droplets in their photoreceptor cells, tiny colored filters that sit in front of the light-sensitive cells and shift which wavelengths each cell responds to most strongly. These oil droplets effectively fine-tune the 4-channel color system, giving birds even finer discrimination between similar colors than the basic 4-receptor system would produce on its own. The result is a color vision system so precise that researchers who have modeled it computationally estimate birds may be able to distinguish color differences that are completely indistinguishable to human eyes. The yard you see as green in summer is not a uniform green to a bird. Every leaf, every blade of grass, every stem has a slightly different spectral signature that the bird's oil droplet enhanced visual system is reading continuously. What looks like a backdrop to you is a detailed map of surfaces, textures, and compositions to the animal sitting in it. Number 6. What your feeder actually looks like to the birds using it. Take everything we have just covered, the UV channel, the higher photoreceptor density, the sharper acuity, the wider field of view, and apply it to the most specific and familiar object in your yard, the feeder. To you, your feeder looks like a feeder, a container of seed, familiar, functional, probably a bit weathered. The seed inside looks like seeds, brown, muted, indistinct. To a bird, your feeder is a landscape of information. Many seeds reflect UV light in patterns that make them visually distinguishable to a bird in ways they are not to you. A sunflower seed and a millet seed that looks similarly gray-brown to your eyes may look dramatically different to the chickadee selecting between them. One may have a UV bright coating that signals higher fat content or fresher condition, or some quality that the bird's visual system has evolved to read. The feeder itself, its surfaces, its perches, its age, and weathering contains UV reflective information that affects how comfortable birds feel approaching it. Research on bird feeders has found that certain surface treatments, molds, and weathering patterns that look the same to humans appear different to birds under UV examination. A feeder that looks clean to you may read differently to a bird whose eyes are sampling the UV spectrum of every surface it approaches. The birds at your feeder are not just eating. They are reading the feeder the way you might read a menu, assessing the contents, the quality, the freshness, through a visual system far better equipped for that assessment than anything you can do with your eyes. Here is a practical implication of this. When you put out fresh seed versus old seed, you may not be able to see much difference. The birds can. When you put out a clean feeder versus one with weathering and mold beginning to develop on its surfaces, you may not notice much change in appearance. The birds notice. The visual information they are gathering at your feeder every morning about the quality of what you are providing is far more detailed and accurate than anything your eyes can tell you about the same setup. The birds that keep returning to your feeder are not doing so blindly. They are doing so because the visual assessment they perform every time they approach tells them this is a good source, maintained by a reliable presence, with seed that reads as fresh and appropriate. You have been passing a quality inspection you did not know was happening, conducted by eyes better than yours every single day. Number 7. What you look like to the birds in your yard. Human skin reflects UV light, not uniformly and not in ways we can see or control, but in patterns that are visible to birds with tetrachromatic vision. Your face, your hands, your arms as you move through the yard are not the same muted skin tones to a bird that they appear to you in the mirror.
Researchers studying human UV reflectance in the context of bird vision have documented that different skin tones, sun exposure, and even the use of certain sunscreens or moisturizers change the UV signature of human skin in ways that a bird can detect and that we cannot perceive at all. The person who has been gardening in sun all summer looks UV different to the birds than the same person in early spring. The hands that refill the feeder have a UV signature that the birds at that feeder have been seeing every time those hands appeared. This adds a layer to everything we have discussed on this channel about individual recognition in birds. When a chickadee recognizes you specifically, when its memory system suppresses the threat response for you and not for your neighbor, part of what it is recognizing is a visual signature that includes UV components you cannot see in yourself. The birds know what you look like in a dimension of your appearance that is entirely invisible to you. You have a UV face. The birds have been seeing it all along. Number 8. What this means for everything you have ever watched in your yard. Take a moment with this, because it changes the retrospective meaning of every observation you have ever made. Every cardinal you watched and found breathtaking, he was more than that. Every flower in your garden, it was covered in directions you could not read. Every migrating bird that landed in your yard after an overnight crossing, it had been navigating by a compass you cannot perceive. Every bird that recognized you and stayed close, it was seeing a version of your face that you have never seen in any mirror.
The yard you have been tending, the feeders you fill, the native plants you grow, the water you keep fresh through winter, all of it exists in a world that is richer and more complex than the version available to your eyes. You have been building something in a universe that is larger than the one you can access, and the birds you have been watching have been inhabiting that larger universe every single day. This is not a small thing. Most of what makes a bird, the navigation, the mate selection, the food finding, the threat detection, runs through a visual system that is simply not available to human perception. You have been watching the surface of something that goes much deeper than you could see. The yard you built is even more alive than you knew. The birds in it are even more extraordinary than they appeared. And the world they live in, which overlaps with yours in the same garden every morning, is bigger and stranger and more beautiful than anything your eyes have been able to show you. There is something worth sitting with at the end of all of this. You have been tending this yard. You have filled the feeders and kept the water fresh and planted the native flowers and put up the nest boxes. You have done all of that in a version of the world that was available to your eyes. And in doing so, you have built something that exists and is experienced in a world that goes far beyond what you can see. The cardinal that visits you every morning experiences your yard in full. The UV signature of your planting, the navigational context of your yard within the broader geography his visual system reads, the precise quality of the seed you put out, assessed through eyes that can distinguish what yours cannot. He sees more of what you built than you do.
That is not a diminishing thought. It is the opposite. You have been building something for a world richer than your own perception, and the birds have been living in it fully every morning, while you caught whatever glimpse of it your 3-channel eyes could offer. Tell me in the comments, knowing now what your birds can see that you cannot, does it change the way you think about the cardinal at your feeder, or the flowers you planted for the hummingbirds? I want to hear what lands hardest. I read every one. I'll see you in the next one.